and look into R. We were already there, but let's try to check the normal, see if we have some normal distributions among you. If we have some data to support it, if I can find it here. There we are. Just do like this, and I'll do a copy-paste here. So that's from the little poll I gave to you. We had some age values, we had some height values. Let's see, mean age, mean height. You are on average 23 years old, you are on average 179 centimeters. But are you also normal? Let's find out about that. QQ norm to your age. Is this a normal? What do you think? Is it a line? Not exactly. But then again, here is the challenge of this tool. We would never expect an exact line, right? Let's make this thought experiment into, let's have the computer help us to be intelligent about looking at this plot, right? How many age numbers do we have here? Length. Probably I could see it up there, but I'll just check. What is the length of the age list? That is 28. Thank you to the 28 who answered, who played along with us here and gave their ages to us. It's a sample of 28 people. How would a normal plot look if we really had 28 samples from a standard normal? By the way, it doesn't really matter which mean and variance, because this way of plotting, it produces a line anyway. It's just the position of the line and the slope of the line is related to the mean and the standard deviation. We don't have to think of that. Let's think about how does a normal plot look when I apply it to something which is really normal, and 28 of them. Let's have a look at that. This was only one of them. Let's see. Here's what we can expect. Here's the type of noise, the type of expected variability when we look at the normality of 28 points. Of course, 28 points will not exactly follow a line. They will sort of shift, or they will... but let's have this feeling of this randomness given in those plots in our stomach, as a gut feeling. And then let's look at this one again. Whoa. You don't seem to be particularly normally distributed on your age. Of course, it would have been obvious to have a look at the histogram at first place. Not a very nice histogram. Number of class equal 12, like this. It seemed that we have what I would call a type of kind of right-skewed distribution here, right? We have a few, too many many of you are in here, typical students, and then we have some that are a bit older here than the typical student. Let's just, for the fun of it, see how would it look if I applied the log transformation to the age here. Let me see. That's what I do here. Maybe I should try to remember that I'm going to share this with you afterwards, so that we have both of them there. Let me do the histogram first. Doesn't seem to help a lot in this case, actually. Let's look at the QQ norm. Maybe a tad better, but not really a lot. So really, it's a tough right-skewed distribution. That is a departure from normal. Next time we'll have a feeling of how important... don't leave yet. I didn't finish, even though I start talking about next time. we'll see how severe a problem would this be to us, this lack of normality, which is clearly the case here. So there is a lack of normality here. What about the, let's see about the height. Was that with a capital H? Like this? What about QQ norm on our height distributions? That's a normal distribution. At least we cannot distinguish this from a normal distribution. Slightly odd, maybe. Why would that be slightly odd? Would we expect a random sample of U to follow, let me then emphasize this, one simple, the same normal distribution in terms of heights? I can identify at least two segments in here that on average have different heights. Right? We are males and we are females. But maybe we don't see it in small samples. That's another case. We don't see it here. It seems quite normal. I don't know the sample. Maybe it's only males who answered it. So probably not. But nevertheless, we don't see it in these numbers. That was playing around with normal distributions. Don't leave me. We have one more thing, so we make the last